What are atoms made of?
All of the above.
Okay, if I was to take an atom and raise the nucleus to the size of a head of a pin, where would the nearest electron ring be?
You've said it before, but I cannot.
About 300 miles, 300 yards away. Atoms are mostly empty space. Atoms with many electrons in their valence rings make good conductors. All right, now here's what a valence ring is all about. And I'm not going to draw this 300 yards away, but basically you got, this inner ring, and then the outer ring is the one that's your valence ring. Okay, now I'm blowing the lid on some of these things early on, but if you've only got one electron in your valence ring, it's a really, really good conductor. Do you know I have a test? Oh, I'm sorry. Let me know if you run into a problem like that. Okay. See if there's one in that stack. I bet there's not. You not got one?
I found one of mine, it's almost all the way in the back.
All right. Just take your other paper and put these answers down, because you're going to hear everything I've got to say, and then I'll give you a copy of the test after we're done in here. Because we got to keep moving on this. Sorry about that. I thought I had put everybody the same thing in their stuff, but everybody in here is taking electrical. All right. Just like I say, just listen to what I'm saying and write it down on paper or something, and then I'll give you another one later. And I apologize for that. Atoms with a lot of electrons in a valence ring make good insulators, not conductors. If you've got 8, you can't have more than 8 electrons in a valence ring. If you've only got 1, that's something like gold or copper. If you've got 4, it's a semiconductor, and that's what transistors are made of. Got it? So if you've got 4 of them, certain conditions have to be met before current will flow. Like a diode will only flow one way. A transistor's got to have it's actually made of some diodes and all that. So remember, if you've got 4 rings, 4 electrons in there, because what happens is it gives a lot of path for flow. If this is full, then there's no room for anything to move. You got to have holes in there for the stuff to flow through. You know what I'm saying? It's like having a stopped up piece of pipe that nothing will flow through. An insulator would be like the plastic or glass or even air or something like that. Water without minerals in it, I had heard somebody say won't conduct electricity unless it's got minerals in it, because the minerals are what enables it to conduct electricity. Electrons are positively charged, that's current flow, and that's wrong. That is absolutely false. Electrons are negatively charged. Electrons are negatively charged, and so, electronic theory says power flows from negative to positive, and electron flows from negative to positive, and conventional theory says it flows the other way. Just remember that too. Most modern vehicles have which terminal connected to the vehicle flame? The negative one. Batteries have twice as many positive plates as negative plates. That's false. A blank is or necessary for all electrical circuits. You've got to have a power source, you've got to have a ground path, you've got to have a load with resistance, all of the above. All right? That's number 6. All right. What uses electricity and turns it into work?
Load.
That's going to be a load, which would be like a motor or a light or something like that. Current will flow if charge is available, switch is closed, the circuit protector is not open, all of the above. Now think about this on batteries. Basically, what are you doing when you charge a battery? What are you changing on the inside of that battery when you charge it? What makes it charged versus not charged? You're putting all the electrons where they don't want to be. And they're looking for a way to get over to where they want to be. And if you can give them a path to go from where they don't want to be to where they want to be, current's going to flow, work's going to be done. You always hear me talk about my little meters over here, my yellow meters that are made to measure amps. And when you put that thing on amps and you put that thing in the amp hole, that meter becomes a jumper wire. And if you hook it to the positive and negative side of the battery, you destroy the meter, or you destroy its ability to measure amps. It's just like hooking a jumper wire up. How many of you have smoked a jumper wire? You ever smoked a jumper wire? Does that make you feel really good when that happens? You've never smoked a jumper wire? Don't worry, you will. Everybody in here smokes at least 2 jumper wires the first time we start out doing all this kind of stuff. And it just, one little piece of jumper, and this is electrical, this is an automotive electrical lesson I can teach you. One piece of wire that long, just one little piece of wire that long, can fill the whole cab of your car up with smoke. Doesn't mean you've burned lots and lots of wires if your whole car fills up with smoke. One little 6-inch wire can fill it up, all right? Is there somebody here? There she is. She brought it. She brought some stuff. Valve cover gasket. Let's see. Ohm's law states what? Somebody tell me about Ohm's law. Remember it?
No.
1 volt pushes 1 amp through 1 ohm. Can you remember that? Say that. 1 volt pushes 1 amp through 1 ohm. Volts is pressure. Amps would be flow. Ohms would be resistance. In the PowerPoint presentation I usually do on this, I got a water hose out there with water flowing out of it. I put my boot on the hose. I pinch the hose. Unless, that sounds like it may rain. It's supposed to be raining about this time of day according to what the weather said.
That's my luck.
Huh? Are your windows down?
Part of it.
At first I thought something fell off the back of a truck.
Huh?
I said at first I thought something really, really heavy fell off the back of a truck.
Like they broke the lead or something?
Or a wheel fell off the truck.
1 volt pushes 1 amp through 1 ohm. 1 volt pushes 1 amp through 1 ohm. Remember this now. Remember the little EIR thing. Anytime you got, if you got 12 volts here and you got 4 ohms there, you're gonna have 3 amps here. 3 times 4 equals 12, right? So you're gonna see this symbol as, actually this is actually EIR. This is volts, that's resistance, and that's amps. I actually said that backwards a minute ago. So you're gonna see this, and there's gonna be worksheets where you gotta use that. That's the EIR. That's Ohm's law. Now, are you gonna use Ohm's law fixing cars? Probably not, but you need to understand it, right? Okay, it's not hard to understand either. An increase in resistance will also cause what? What will current flow do if resistance increases?
Decrease.
It will decrease because it's actually slowing the current down. It's like my boot on the hose.
What was it?
Number 8 was D. All right, as in delta. 11, how many amps will 12 volts push through 4 ohms?
3.
3, that's what I just said. Current is a measure of,
B.
who said something?
B.
Oh, B, yeah, I'm sorry. Baker. If 2 6-ohm bulbs are connected in series, their combined resistance will be what?
3.
In series means what?
They're added. It's 12.
Yeah. In series, that's a bulb, that's a bulb. This is in series. Got that? Right? Now on the other one, this is a bulb, this is a bulb. And that is parallel. Got it? Parallel series, parallel series. Everybody get that burned in, right? Current is a measure of what?
We just did
Amps, we just did that. Sorry, copper wire has no resistance.
false.
That's actually false. If you got a piece of copper wire 60 feet long that's just stretched out straight, it'll have a 1 ohm of resistance because of the distance. However, there's other things going on too. If you got a copper wire, that's the motor wire, you know, that's the, well, this kind of wire right here, that's on this thing right here. This little motor wire here, that pretty wire, that wire has got shellac on it. That's not just copper wire that's touching each other. The current that flows through that is flowing through the wire, but it's not flowing from wire to wire. You understand what I'm saying? That's all one piece of wire right there typically. But anyway, the long and the short, or I say that, they may have, you know, pairs of them, but the long and the short of it is, that particular thing there, did you see me catch that before it landed on my keyboard? That was fast, wasn't it? All right, but anyway, that particular wire, when you run current through that, the magnetism and the current flowing through that wire causes it to have resistance. It's called, some people call it inductive reactance. I've heard it called inductive reluctance. So there's going to be more resistance there because of the magnetic field that's surrounding it because of the current flowing through it. So it sort of builds on itself. Let me see. The blank of all voltage drops in a circuit always equals the what?
Oh, the source voltage.
That is a question that's not finished. The sum of all voltage drops in a circuit always equals the source voltage. What do I mean by that? I'm trying to hammer this stuff really, really swift here. Right here, we've got a resistor, and I should have drawn that a different way. And this right here, we got a bulb, and right here, we got a switch, and right here, we got B plus, and right here, we got B minus. You know, and it's basically, all right, so we're hooking all these together, we close the switch, and every time we hook our meter up, see, let's say that our source voltage is 12 volts. We're going to say 12 volts even. Okay, so if we hook our meter up right here and right here, it's going to read 12 volts, right? What are we measuring when we do that? Voltage drop across the entire circuit, which is going to be equal to source voltage. So our source voltage is equal to 12 volts, and our total voltage drop is also equal to 12 volts. However, if I take another meter and I measure right here, and I get 3 volts, what does that mean? That means 3 volts is being lost right there. Now, why is that smart? Because you can take a meter and you can go from the post, the center of the positive battery post, to the stud on the starter solenoid, and you can have somebody spin it over, and if you're reading like 3 volts when they do that, that means you're losing 3 volts between the battery and the starter, and that's why the darn thing's spinning slow, and somebody's already replaced the battery in the starter, and it's just like it was. You hear me? I mean, you got a bad battery cable can cause that kind of thing too. Now, one time there was this farmer that called me, and he says, "Can you see why my tractor won't start?" And heck, I guess I was like 18 or whatever. And I went over there, and I didn't know anything about voltage drop and all this kind of stuff. I understood it, but I didn't know it by that name, and I didn't have anything to measure it with. But what he had was these molded battery cable. I ain't talking about the ones with the screws. It was molded on there, and the copper that was supposed to be making contact with that battery cable inside there was not doing anything. The battery was good and hot, but even when you hook jumper cables up, the tractor still wouldn't start unless you hooked the jumper cables directly up to the starter, and then they would start, because you were bypassing this voltage drop that was coming from between the positive battery post and the cable. Even if you went to the positive battery post and the cable that far away, you were dropping every bit of the voltage. There was nothing there. So that's what voltage drop's all about. If you don't understand it, don't worry. You're going to get to do some worksheets on it. And once you understand voltage drop, it ain't even a big deal. Some of you guys have already done some of the stuff in other courses. All right, let's go here. Voltage drop is basically a measure of, what did I just say? What was that? What did you get out of what I just said up here? How much voltage is being lost or dropped in a particular part of the circuit. Sometimes voltage drop can be our friend. If we don't want our fan blowing high, if we just want it on low, then the resistor in the dash is going to actually stop that. But where there's resistance, there's heat, and that's why the blower resistor is in the airstream, so it can keep it. Well, I told you that little story about that lady that I saw sitting beside the road. And have you ever seen somebody sitting beside the road with her hood up, and there'd be 4, 5, or 6 guys there trying to figure out what was wrong with their truck? Yep. And so, I pulled over there, and I says, I said, what's going on here, And they said, well, she's all of a sudden a bunch of smoke come out of the dash, out of her air conditioner register, and we were just trying to figure out what was wrong. They had the hood open, they were looking around under there. And I said, well, let me see what I see here. So I opened the hood, opened the car, or the door, and I smelled of it. It was a Ford Explorer. And I said, I smell burning leaves. And I said, I tell you what, if you turn off the fan, roll the windows down, and drive it to a shop, and get somebody to clean the leaves out of your evaporator case, you'll have to take care of this problem. Because I noticed she was running the fan on low, and there's a lot of heat in that resistor in there, and those leaves that got caught on the resistor, and it set fire to those leaves. It wasn't really open flame, but she was getting smoke out of the register, and it alarmed her, and she pulled over and stopped. And she had 618 mechanics out here looking around under the hood trying to find out why she smelled leaf smoke inside the car. Anyway, let me see, where am I at here?
18.
Oh, if a bulb in a circuit with a 12-volt power source is only receiving 6 volts, how much voltage drop does the rest of the circuit have?
6 volts.
Sounds like a good answer to me. In a parallel circuit with 3 resistors, each having 3 ohms, the total resistance would be?
1 ohm.
1 ohm. You got that? What do you think? Parallel circuit. 3 ohms. 3 resistors having 3 ohms. How do you know this? Remember? Did I tell you that?
Divides.
Huh?
Parallel divides
It does, and it's always gonna be less than the least. Does everybody get that? When it's parallel, if you got, let me ask you this. I got a resistor here and a resistor here, 5, 5. All right, now I'm gonna hook my meter to both sides of this. Hooked up to ohms. What am I gonna read for ohms?
2.5.
2.5, because you're gonna, basically the formula, you know, is 5 times over 5 plus. You know, 5 times 5. What's 5 times 5?
25.
What's 5 plus 5?
10.
All right, so that winds up being 2.5 ohms, right? How many times will 10 go into 25? 2.5. Got it? That's not complicated, is it? Are you good at math?
My WIA test would say no, but I'll pretend that I am.
Yeah. On schematic, the top of the page is typically what?
Or
All right. Top of the page is typically power on the top. Remember, when you're looking at a wiring schematic, ground is going to come in from the bottom, power is going to come in from the top. Always remember that. Easy to do. All right. If I draw a schematic symbol up here, everybody in here will be able to tell me what it was, right? What is that?
it's a really messed up smiley face.
It's a circuit breaker. If I drew it like this, it would be a fuse. You hear me? All right, what if I draw one like this? That's a heater. See what I mean? I mean, that's sort of looking at a schematic symbol, it's not really that complicated because it gets to where it's just second nature. When finding an electrical problem, it's important to be able to do what? Locate components, locate connectors, locate grounding points, all of the above. If you're looking at something that doesn't work, you need to know where the components, where the connectors, where the grounding points are. And what I check when I'm looking for any kind of electrical thing, I want to know what's easiest to get to. If things are starting at the ignition switch, you might think, well, I'm going to start here and go down. Well, at the same time, if the ignition switch is under the dash and buried under the knee bolster and all that kind of stuff, I'm not going there first. I'm going to go to the connector that's out there on top of the engine. It's a little easier to get to. I mean, you got to learn not to fall into those traps. The top hot button on a GM schematic leads to what? Yeah, that's the locator page, basically. It tells you, so you can go and find where the stuff is. Delicate electronic circuit should be checked with a,
Test light.
they say with the digital multimeter, and that's true. But there are some instructors that will tell you never to use a test light. That's a bunch of hogwash, because if it won't burn a test light, it's not going to do the work either. You know what I mean? I mean, like for instance, if I unplug my power window motor because my power windows ain't working, I may put my meter there between those two and read 12 volts, but it may not even burn my light. So if I got a test light there, heck, use a headlight bulb. Make sure that it'll light that headlight bulb. If it'll do that, you know it'll run that power window motor. See what I mean? In the school, in KC Vision and these places where I go to get training, every single one of them says if you've got a ground that you suspect being a problem, test to see if that, hook a headlight bulb up to power and touch that ground and see if a headlight bulb lights up good and bright. Because if it doesn't, then you've probably got some problems on that ground circuit. But if you measure it with a meter, it's going to tell you it's perfect, even if there's just any kind of whisper of one piece of copper there. Throttle position sensors change their resistance according to
Movement of the throttle plate.
movement of the throttle plate, and finally a solenoid converts electrical energy to mechanical movement. Does it?
Yeah.
All right then. Now, our class sessions are not all going to be this long, but this one has to be because I got to get caught up with all this stuff. And you guys that didn't have tests, don't let me forget to give you one. And
Hey.
as a matter of fact, let me whip through these right here right quick, and we're going to be, when we get through with this, we're going to go to lunch. The way that the lunch works nowadays, since the head shed up there, and you won't see everybody clear it out of here and go to the student center or wherever during lunch. I mean, so they don't want anybody in here eating lunch. I don't like that, but anyway, just whenever we get ready to close, we close all the doors, we lock the shop, we all go somewhere else, including me, right? I mean, I could stay if I wanted to, and if I stayed, y'all could stay, but I don't stay here to eat lunch. The atomic structure of an atom includes, we know that one. Protons, neutrons, and a nucleus, right? That's wrong. Protons, neutrons, and electrons. Copper is an excellent conductor, is that true?
Yes.
Direct current is used in automotive vehicles, is that true?
Yes.
Where do we find alternating current in automotive application?
Alternator?
That's one good answer. What about wheel speed sensors? A lot of wheel speed sensors. Crank sensor on front of the engine makes alternating current. Voltage is equal to the current divided by the resistance. Is that true? That's false. It's multiplied by the resistance, correct? Resistance is the opposition to current flow. That's true. All right, you got them? Write them down. Don't forget. This is another one. Logic probes are sometimes called electronic circuit testers. That's true. Logic probe basically got LEDs in it that turns red or green based on whether you got ground or power. I got one of them here. A positive lead on a multimeter is usually black. That's totally false. It's always red. It's common for a circuit to have series and parallel connections in the same circuit. That's true. A short circuit occurs when two connectors touch each other. Conductors touch each other when no connection is intended. That's a good definition of that. And finally, plastic, rubber, and glass are three materials commonly used as insulators, not resistors. Okay, won't take us very long here. We're not going to do the matching part of this test, by the way. We're just going to do the multiple guess. What if the resistance of the voltage is 12 and the current is 2 amps? What's the resistance of the circuit if the voltage is 12 and it's going to be 6 ohms, right? This is just basically hammering in what we did earlier. Diodes, Zener diodes, light emitting diodes, transistors, and thermistors are what? Solid state devices made using combinations of the basic p-n junction. That's the 4 electron valence ring stuff. To prevent voltage spikes, what's commonly used? Now that's a question you won't know if I hadn't told you. Huh?
Is it a transistor?
No, it's actually a clamping diode, and I'll show you what I'm talking about here. Copper winding. Air conditioner clutch, right? What happens whenever you have a magnetic field that is broke, you know, you break the switch, like you open the switch, you got B plus here, this going to ground, you open this switch, this magnetic field that was actually pulling that AC compressor clutch in there is going to collapse. And when it collapses, there's going to be about a 400 volt spike that goes screaming out of this thing, you know, back somewhere. And if it happens to be tied into a circuit that a PCM's reading, the PCM's going to go, you know, it's going to basically punch it in the teeth. So how do you fix that? Remember, this is B plus, right? So I'm going to put a diode right here. Cannot go here. It's only going to go there. But when you break that, it's basically going to cause this to chase its tail and go away. You know, the spike will chase its tail through that diode and it'll go away instead of going screaming back in there. I worked on a Daleville Cablevision truck one time. They brand new truck. It just had a plain old AM FM radio in it. But they said this thing eats radios about once a month. And everybody in the shop has put a radio in it, and now it's up to you to make sure that never happens again. And they had an AC style compressor clutch operating the power takeoff for the bucket, for the hydraulic pump for the bucket. And when they wired it up, they just wired it up. It didn't have a clamping diode in there or nothing like that. And the way I found it was, I was hooked my oscilloscope up to the power lead going into the radio, and I started turning stuff off and on, stuff they had added. And when I turned that hydraulic pump off, I saw a spike on that oscilloscope that went slam off the screen. And I said, wonder this radio's lasting a month before it fries it. And so all I did was go to Radio Shack and picked up $1 and something diode and soldered it in there, and that problem never happened again. See, that was the, you know, one of those things there. That's a clamping diode. Remember the name of that. I'm giving you a bunch of basic stuff today that you're going to carry with you through the rest of the semester, and it seems like it's usually our class session lasts about 20-25 minutes, you know, so this is longer than we've ever usually do. Let's see, according to Ohm's law, what? You know the answer to that? All of the above, believe it or not. E equal I times R, 1 equal I divided, I equal I divided, E divided by R, and R equal E divided by I. So I, if A is right, then B and C ought to be right too. Voltometers, test lights, scan testers, oscilloscopes are all used to test.
I think it's supposed to be D, but I'm pretty sure D is supposed to say both B and C.
Yeah, you're right. Both B and C is, that checks solid state components and electrical circuits. Finally, an electrochemical device that supplies current to the starter and ignition system and to vehicle electrical systems when the generator cannot handle the load is called a what?
Battery.
Battery. They're not gonna, forget about the matching stuff, we're not gonna do that. All right, just put an X over your matching questions. And, I will print you two, the ones of you guys that got stiffed on the electrical test, I'll print you,
I'll